Hello everybody, my name is Sabrina Santarossa and I'm Sales and Business Development Manager for Industrial Heat Recovery in Turboden. Today I'm here with my colleague Andrea Barbon to present you the technology produced by our company and to explain how it can be applied in cement plants to increase process efficiency.
Hello everybody! As introduced by Sabrina, I'm Andrea Barbon, Sales Engineer for Industrial Heat Recovery application. Nowadays, words like climate change and sustainability are becoming more and more common, and also cement producers should take part of this global challenge.
In our presentation, we will answer your question about what technology can improve the sustainability and emission footprint of the cement industry, explaining both technological and economical aspects of the waste heat recovery system, based on organic ranking cycle technology. So, let's see in detail what are we going to talk about. Firstly, we will introduce Turboden company, giving details about the possible application of the ORC, and having a quick talk about our history and our global experience. Then, we will focus the attention on Turboden experience in heat recovery application, and in particular in cement industry, explaining when, where and why it is convenient to recover the residual low-grade heat by means of ORC technology. There will be a quick overview of the working principle of our product, highlighting all the main differences between ORC and the traditional steam ranking cycle. Later on, we will show you cement market trend, and we will explain why we think the ORC is the best choice to produce electrical power by recovering the waste heat. We will then jump into our references, and lastly, we will show you some typical investment figures, showing all the parameters that improve the waste heat recovery system business plan. Since its foundation, Turboden's mission has been to provide reliable and proven technological solutions for the enhancement of energy efficiency and for the valorization of renewable energy sources. The company was founded in Italy in the 80s by Mario Gaia, a professor at the University of Milan. The first 15 years were dedicated to research and development, and some small pilot plants were produced. Nowadays, Turboden is a global leader in the design, manufacture and maintenance of organic ranking cycle systems, highly suitable for distributed generation. ORC system can generate electric and thermal power exploiting multiple sources, such as renewables, waste incinerators, engines or gas turbines, as well as waste heat from industrial processes. The size of the ORC ranges from 500 kW up to 20 MW with a single turbine. Turboden is part of Mitsubishi Heavy Industries. In fact, it owns 51% of Turboden shares. MHI is one of the world's leading heavy machinery manufacturers. It is involved in the power system business, industry and infrastructure, aircraft defense and space. Turboden is part of power system domain, and it can leverage the strength of MHI Group both on technical and financial support. Here we present our growing experience, both in terms of number of plants and cumulated capacity. The industrialization of the product started at the end of the 90s, when the first ORCs connected to biomass boilers were installed and started to spread into Europe. It was in 2010 when the first ORC for waste heat recovery in cement started up, a 2 MW ORC unit for cement to Morocco. As said before, in 2013 we were acquired by Mitsubishi Heavy Industries, and starting from then the size of the ORC has increased, and now the largest ORC turbine can produce up to 20 MW. Today we count almost 400 units, with accumulated capacity of 660 MW. In the last years, we have also developed other products, like gas expanders and large heat pumps. Here a map showing the countries where ORC are installed. As you can see, we are present in 45 countries. Most of the 392 ORCs are in Europe, and several are installed in North America, in Turkey, Japan, and Southeast Asia. The total cumulative operation time reaches 17.5 million hours, with more than 22,000 gigawatt-hour produced from both renewable energy and heat recovery plants. Another important figure reported in this slide is the average availability, which is higher than 98%, measured on a statistic base of all our plants in operation.
Focusing on waste heat recovery application, out of the 392 Turboden ORC plants, 34 are installed in industrial plants for a total of 80 MW installed. 30 of them are already in operation worldwide in several industries like cement, glass and steel. Turboden ORC units can produce electricity by recovering residual low-grade heat from industrial processes and also from reciprocating engines, gas turbines operating on open cycle. It is possible to combine the heat from different heat sources and feed one single ORC. Here a list of reasons explaining why to choose ORC for energy efficiency. First of all, to generate profit, leveraging a heat source that now is wasted. In addition, there is a reduction of specific production cost by decreasing energy demand. Of course, energy-intensive industry sustainability improves and there is a reduction of CO2 emissions. The hot exhaust gases produced in the rotary kiln are firstly used in the cyclones to preheat the raw material and then, at a temperature of approximately 350 degrees, could be transferred to a heat recovery exchanger where the residual heat is recovered by heating up an intermediate fluid. The second heat source is the clinker cooler, where the hot clinker produced in the kiln is cooled down using ambient air. This hot air at clinker cooler's outlet is typically available at temperature between 250 degrees and 350 degrees and can be recovered using a second heat exchanger. This waste heat, transferred to an intermediate fluid circuit, is then sent to the ORC unit. In the ORC, the thermal power is converted into electrical power by means of ORC turbine, and the excess heat could be dissipated in the atmosphere by means of air-cooled condenser without water consumptions. The electric power produced can be used to feed cement plants' load, reducing electric power purchased from the grid. A scheme of the waste heat recovery plant and integration in the cement process is here shown. The two separate heat recovery exchangers are installed in bypass to the main gas duct. The two heat exchangers have different technical features due to the different characteristics of the exhaust gas, and they are optimized case by case. The heat contained in the exhaust gases is typically transferred indirectly using an intermediate loop to the ORC plant, which produces electric power. The amount of electric power counts for 10 to 30% of the cement plant electric consumption, meaning that the monthly electric bill reduces of the same percentage. After having seen the scheme of a waste heat recovery system in a cement plant and the main components to be installed, now we would like to focus our attention on the working principle of the organic rankine cycle, watching this short video.
The heat is conveyed to the ORC system by an intermediate thermal oil circuit. The ORC working fluid, pressurized by a pump at the correct evaporation pressure, reaches the preheater and then the evaporator. Here it is warmed up and vaporized, allowing it to expand in the turbine, thereby generating useful power. The power generated by the turbine is converted into electricity to cover the captive consumption of the cement plant or to be sold to the grid. After the turbine, the vapor enters a regenerator for internal heat recovery, and it is then cooled down and condensed in an air condenser. Lastly, back in its liquid form, it is conveyed to the hot well, from where it is reintroduced into the cycle by a pump. Now that you know how an ORC works, you may ask yourself, what are the differences between ORC and the traditional steam ranking cycle? First of all, the ORC uses an organic fluid instead of water. Several families of organic fluids can be used. Turboden has used up to 10 different organic fluids like refrigerant, siloxanes, and various types of hydrocarbons. The main thermodynamic difference between the two cycles is that water steam must be superheated before expanding into the turbine, while organic fluid vapor doesn't need to be superheated. So the saturated organic fluid vapor can expand in the turbine without possible liquid formation. The expansion is always dry thanks to the shape of the liquid vapor equilibrium curve. This means that in ORC turbine there is no risk of blade erosion. On the contrary, steam turbine blades may be damaged by water droplets that can be formed when superheating is not at the proper level. Sometimes we do superheat, but it's done to increase the electrical efficiency of the cycle. We could explain some other technical differences, and if you are interested, you can contact us later on. Now we would like to focus more on the practical differences. Which are the advantages for a cement producer to have a waste heat recovery plant based on ORC instead of steam? ORC does not have water and does not consume any water, so there is no need of water treatment plant, like in a steam-based WHR plant. The water used in the steam turbine needs a specific quality, and so there is a need of a water treatment, and to control the quality of water sent to the turbine. Steam turbine needs also to be supervised continuously, while ORC has a high level of automation and there is no need of any supervisor, allowing the cement operators to focus on core business. Furthermore, no measure overall are needed in an ORC, while steam turbine need periodic measure overall. Furthermore, no measure overall are needed in an ORC, while steam turbines need periodic measure overhauls. High operational cost leads the steam ranking cycle to be a technology more convenient for plants larger than 15-20 MW, and when the gas is at high temperature. Other differences are related to the low flexibility of steam with lower performance at partial load. On the opposite, ORC has a high flexibility and wide operational range. In fact, it can easily work between 10 to 110% of nominal load, with an average availability higher than 98%. These two factors are important to maximize the energy produced per year, that is a combination of power produced at the different operating loads and the plant availability. Looking in detail about partial load behavior, from the graph shown here, it is possible to see how the electrical efficiency varies when changing the thermal load input to ORC and steam turbine. While ORC maintains a high efficiency even at partial load, steam technology has a stronger decrease in electrical efficiency when not working at design condition. When ORC is fed by half of the thermal power, the electrical efficiency is 90% of the nominal one, while in a steam turbine is much lower. Besides good partial load efficiency that can follow the variation in cement production, ORC is a technology that can leverage the low temperature heat sources. This is well combined with the fact that new cement plants are becoming more and more efficient, and consequently the gas temperatures available for heat recovery are lowering. I would like to recall the attention to the possible ORC configuration with no water consumption. As you know, lack of water is already an issue in several countries, and soon it will be an issue worldwide. So, a solution that avoids water consumption should be considered by every cement producer. Waste heat recovery is not a new topic in cement industry. There are already several plants in operation since 20 years, but the potential is still huge. As reported in the bar chart, there are several countries with a potential higher than 100 MW, for a total cumulative WHR potential in cement plants higher than 2 GW, which correspond to more than 7 million tons of CO2 avoided emissions. To give you an idea of the quantity of CO2, it's like 36,000 trucks traveling in a year, for a total kilometers of 3.6 billion.
As said, Turboden has already several references in waste heat recovery systems for cement factories. The first one started up 10 years ago in 2010. In the table there is a list of these plants. Installation sites are in Europe, Turkey and Morocco, recovering heat from kilns ranging from 2.3 thousand tons of clinker per day up to 7.5 thousand tons per day. Several international groups as Lafarge-Holcim, Heidelberg, CRH selected repetitively Turboden as ORC supplier. The heat is recovered from both preheater and clinker cooler or from only one of them, depending on the specific characteristics of the cement plant. There is also a wide variation of heat carriers used. Typical Turboden approach is to customize and optimize the waste heat recovery plant to maximize the electricity produced per year and thus the profit for the customer. The first plant in cement factory was installed in 2010 in Morocco for a cement plant of Italcementi, now part of Heidelberg Group. The heat is recovered by preheater only with an intermediate circuit using thermal oil, and the ORC produces 2 MW. Several ORC followed this first ORC, like a 4 MW ORC unit started up in 2015 in Fieni, Romania, for Heidelberg Group. Heat contained in preheater and clinker cooler exhaust gases is transferred to the ORC through a thermal oil circuit. The condensation of the organic fluid is done in air condenser, thus no water is used nor consumed in the heat recovery plant. Holcim Group developed 2 projects with Turboden, one in Ales, Romania, a 4 MW ORC started up in 2012, and a second one in Rohotnik, Slovakia, here shown a 5 MW ORC unit that is working since beginning of 2014. Also in this case, there are 2 thermal oil heat exchangers in bypass to conditioning tower for the preheater and to air-to-air cooler in the clinker cooler. Thermal oil coming from the 2 heat exchangers is unified to feed a single ORC unit. In this case, an open cooling water circuit is used to condensate the organic fluid. In the last years, our first reference in Turkish cement was put in operation in Çimko, Sanco Group. The ORC recovers the heat from the clinker cooler only, and it produced up to 6.5 MW. An important factor for the selection of ORC technology was the advantage not to consume water. Water consumption is becoming an issue everywhere, and not only in the areas where there is already lack of water. After this first ORC in Turkish cement market, a second one is ready to start up in the next months in Sommet Cimento, a 7 MW ORC.
Finally, our last slide is focusing on the economical aspect of the WHR project. I believe most of you is quite interested in this information. In the table on the left, there are some typical investment figures for different WHR sizes, from 3 to 15 MW, reporting also a range of CAPEX, OPEX, payback time, IRR, and CO2 savings. These figures vary depending on multiple factors that are listed in the table on the right. In particular, here you can see which are the parameters that improves the business plan, leading to a best case scenario. These figures vary depending on multiple factors that are listed in the table on the right. In particular, here you can understand which are the parameters that improves the business plan, leading to a best case scenario. For example, electrical efficiency increases when the heat sources temperature are high, together with a low average ambient temperature. Typical low cost of investment are achievable if there are no layout constraints. Other key elements are the yearly operating hours of cement plant and the electricity cost. Higher, the better. In addition, since erection activities are a significant part of the total CAPEX, the lower the labor cost, the lower the overall investment for the WHR. Furthermore, possible incentives or different financing schemes can also help to increase the feasibility. In general, the specific investment cost decreases for large ORC turbine size, leading to a very good payback time below 4-5 years for ORC units larger than 3 MW. I hope all of you share our vision. We believe in a viable sustainability where renewables and waste become the main source for heat and power generation, thus playing a key role in the global decarbonization path. To conclude, global decarbonization and sustainability are the right pathways to safeguard the world for the next generations. Turboden, with more than 40-year experience in ORC technology, can make a contribution by providing energy efficiency solutions to the industrial sector.
Turboden can offer tailor-made and innovative solutions to minimize the investment cost and to optimize the economic feasibility of the project. The proposed waste heat recovery systems are in parallel with the existing production process, so they don't have any impact on it. ORC units are fully automatic, unmanned, with low operation and maintenance costs. They do not consume any water, they have high flexibility and good efficiency, even at partial loads. In addition, the availability of a waste heat recovery system is high, leading to a maximization of the energy produced and reducing specific production costs by covering part of the energy demand.
As seen in the presentation, the untapped potential of the heat recovery in cement production is still huge. In fact, 30 to 35% of the energy input is lost in the off-gas, and its recovery is one of the key actions to improve clinker sustainability, to fight climate change, and to move the world forward. Thank you for your attention, and if you have a further question, you can contact Andrea Barbon
or Sabrina Santarossa.
Hope to see you soon.
Arrivederci!